Two terms that you might hear about are parameters and statistics, and I want to take a moment to talk about what those terms mean because they're used a lot in inferential statistics. So we have populations and we have samples. And populations refer to every member of the group that we are intending to study. So all American citizens, all middle school age girls, all people over the age of 80 who live in nursing homes, whatever the specific population is for your specific study. But because it would be impractical to track down every single middle school girl in America, instead we choose a sample of them and hopefully generalize the results from that sample to the entire population. But because we've split it up this way, it means that we actually have two groups that we can talk about, the population and our sample. And so in cases like this, we would say that parameters are measures that refer to the entire population of interest, and statistics are measures that refer to the sample that has been drawn out from that population. And so now you know that whenever you hear the word parameter, that it's talking about the population as a whole. But when we talk about statistics, we're specifically talking about things that relate to our sample. Another thing that you might want to keep in mind are the different ways that we talk about populations and samples in equations. Populations and the parameters associated with them are generally assigned a Greek letter to represent them in equations, while samples are generally assigned Roman letters. For example, the Greek letter mu is used to refer to the mean of a population, while this symbol, the Roman letter x with a bar over it, is used to refer to the sample mean. So both of these symbols represent means, but we use a different symbol for that for the population and the sample. Some other symbols that you might come across when looking at statistical equations are this one here, this is the Greek letter sigma, or a lowercase Roman letter s. And both of these symbols represent standard deviation, but the sigma is the standard deviation for the population, and the s is the standard deviation for the sample. And I think that this is helpful to keep in mind, because it can help us better understand the statistics equations that we're seeing. So let's say you see an equation and you don't really know what it's talking about. Knowing that the Greek letters represent populations while the Roman letters represent samples can maybe help you understand it a little bit better. But something to keep in mind is that not all Greek letters refer to populations or parameters. For example, sigma means summation, or an instruction to add certain numbers of an equation together. So while you can use this trick to try to figure out whether or not an equation is talking about populations or samples, you also do need to be a little bit careful about it. And hopefully I didn't confuse you too much by saying that, but I did want to point out this trend to hopefully help you gain insight into the equations that you might see later on.